This is CPM Calculus, Chapter 1, number 41. Why Kit knows that roots can be rewritten using exponents. Study his examples below. These are his examples which we can reference while doing our work. Use Kit's method to rewrite the following radicals using exponents. A. The square root of k to the 7th power. So as you can see, I have the square root of k to the 7th power written here. So using Kit's example, we can see that the square root ultimately equals 1/2 in exponent form. So to begin, we'll keep k to the 7th power in parentheses, and we'll apply the square root to the outside of the parentheses, and the square root is 1/2 in exponent form. So ultimately this just becomes k to the 7th power times 1/2, or times 1/2 in power form. So 7 times 1/2 is just 7/2. So k equals 7/2. Okay, now for B. B is asking the third root of t to the 4th power. So to begin, we keep t to the 4th in the parentheses, and we just apply 3 to the outside of the parentheses, like so. So t to the 4th stays in the parentheses, and then we determine 3, or we get 3 from 1/3, since that's how the square root works in power form. So then it just becomes 4 times 1/3, and that is t to the 4/3 power. Now for C, the square root of n in parentheses to the 4th power. So since square root of n is in parentheses, we'll just apply that first to the power rule, and we keep it in parentheses. So n to the 1/2 power, n to the 1/2 power times 4, it just becomes 1/2 times 4, and that's 2. So n to the 2nd power. And finally, for D, it may look kind of scary since they're big numbers, but it says the 5th root of b to the 31st power. So like we've been doing, we'll keep b to the 31st power in parentheses, and then we'll apply the 5th root outside, and that just equals that. And then it just becomes a matter of 31 times 1/5, and that's b to the 31st, or 31/5 power. Box your answer. And this concludes CPM Calculus Chapter 1, number 41.